So this week what we're going to look at is how to make a very simple 360 video player in Unity using quite a lot of the built-in software tools, built-in things to Unity. So an example of 360 video and a really useful shader that I've included as a download link with the video. Okay. The key thing here is that what we're doing is we're making a video where rather than just playing in front of you, you can actually turn around and it will play all around you. Obviously this is being done on a flat screen, but another video would show you that actually it's really easy to edit and to move this on into VR. So VR at the moment is something that is quite difficult to demonstrate, particularly with the pandemic, but I'm sure we'll get there, and I'm sure we'll be able to show you how to actually implement this in VR to begin your first forays into VR. So we've got Unity, and all I have is a new scene set up, new project, just a standard 3D project, and what I've done is I've done a couple of things. I've imported a sphere, which imports into 0, 0, 0, and I've scaled it up to be 10 units big, so about 10 meters big. And the sphere is what we're going to use to do something called projection mapping. So we're going to project effectively using using Unity built-in video player component. We're going to project onto the inside of the sphere. Okay. But the sphere at the moment has its, as you can probably see, its faces facing out. And if we kind of zoom in and go inside the sphere, actually there's nothing there. As soon as you go inside the sphere, you can't see internal faces. So what we're going to have to do is reverse that so that the inside is facing out and the outside is facing in. Make more sense in a second. What I've also done, just to make it a bit easier, I've stuck our main camera inside the sphere in terms of the position. So I've reset its position to 0, 0, 0, okay, and it's scaled 1, 1, 1, which means that from inside the sphere we now can see outwards. Yeah. So as I said, I've included this shader. So this shader was originally got it from I believe the Theta forums, which I've kind of long since gone. So if you happen to see this and it happens to be your shader, very much thank you. It's made freely available. I don't claim any kind of use for it. Basically, its job is to tell Unity and tell the material it's attached to flip what we call the normals, the bit that show the faces from outside to inside. Probably doesn't make much difference when I tell you about it. So what I'm going to do, I'm going to create a new material, and I'm going to call it Inside Out. And I'm just going to drag our shader on. Okay. So the material, very basic, just as a tiling. You can add a texture to it, but we don't really want to. But if I drag that material onto the sphere, okay, you can see the game view's gone white, and the reason that game view's gone white is because we can now see the inside of the sphere and that kind of white background. Okay. So in order to actually get the video to play, we're going to add a component to the sphere. It used to be that 3 or 4 years ago, so I've been doing this for quite a while. I've got some apps out that have done this and I've done some commercial work for this. When I first started doing it, it was really difficult. I basically had to take some pre-existing assets, modify them, add some custom code, add some custom render textures. Now it's just as simple as going add component, video player, Unity built-in video player, and Unity built-in video player is really nice, really simple. You can choose from a video clip or URL, so you can stream from the web, which you can stream from a standard video clip. The video clip here is where you drag in the video clip, which we'll do in a second. You can choose if you want to play as soon as the game starts. We always wait for the first frame, so basically wait until the first image is ready so it all syncs up. But we want to keep looping, playback speed, all the stuff, everything's kind of straightforward until we get down to here, which is render mode. This basically says where is the video player going to output the video to. And you can see, because it's a sphere, by default it will be set to material override. So we can, if we wanted to, have it project onto a plane. So the camera is far plane or near plane, which is the bit furthest away from the camera or nearest to the camera. So we can have, for instance, a video playing in the background as a nice background, and it will just always be in the background of our scene. We can add it to a render texture, so it could play on a billboard, or for instance, and there'll be other tutorials to show you how to do that. But we're going to use material override. Okay? A material override basically takes the material, takes a thing that's making that object sort of visible and just telling what it looks like, and it will output the video, output the images from the video to its texture. Okay? And you can see it filled everything in for us. Okay? And all I need to do is drag the video clip into the field, and when I press play you can see that we have a nice example of, I'm just going to mute the volume because it's very loud in my ear, a nice example of a video on Tower Bridge in London, and I can, by rotating the camera, I can move around and I can look around, and I can do all sorts of weird and wonderful things. So this video is a free sample by someone called Atmosphere. It's quite a high quality video, so it'll give you a nice viewpoint, but there are plenty of 360 videos out there that you can try, and I'll include some links for you to kind of have a play around your own. So at the moment, literally what happens is we press play, the video starts, and we can, by using the kind of the camera drag tools in Unity, we can kind of look around. Okay. So there's a few things we should probably want to do. Okay. One is to enable to control playback. Okay. To stop and start, maybe to skip to other videos. That's all doable. The second is to actually enable you to look around in the video. Okay. As I said, this is completely doable for VR, and actually it's really trivial to actually add it to VR. It's probably in some ways easier to add the VR look around more than it is the sort of flat screen look around, but I'll show you the flat screen first. Okay, so we're going to start with a simple thing of being able to actually play and pause and perhaps alter the video controls. Okay. This is a simple thanks to Unity's inbuilt UI. Because it's flat screen and because it's not a VR app, we don't have to necessarily worry about setting up the buttons. Okay. So what we're going to do is we're going to add a button. I'm assuming, hopefully, that you know roughly how Unity's UI works. You only need to know the basics. So I've just set my button up. I'm not really worried too much about what it looks like. Okay, I could add images in to make it look pretty. I could change the text to a play symbol. I could do all sorts of stuff. That's for you guys to do. Okay. Instead, I'm just going to have a button near the bottom of the screen, so it's less intrusive, that says play. Okay. And then what I'm going to do, I'm going to create a C# script that lets me actually control this. So if I look at called video playback, and if I open that, just take Visual Studio to open. So what it will be doing is, if I just drag this across, so it will be using Unity Engine.video playback, or sort of video. Okay? So we're going to create a variable at the top called vid player. That's going to hold a reference to our actual video player. Right. Get component video player. Okay. Because what I'm going to do, I'm going to put this script onto the sphere, so I can just grab it by get component. I can make it public and drag it across. It doesn't really matter. And then I'm going to create a new function. Okay. I'm going to call it play pause. So what I can do, I can say, well, we can first start off by saying vidplay.play, okay, which will start playback. Okay. But we only want to start playback if is playing. Okay. So whether the actual content is playing, okay, is equal to false. Otherwise, we want to pause. Okay. So that says if the video is playing, pause it. If it's not playing, play it. We can go back to Unity. Okay. Go to our nice little button here. Let's first attach this script to our sphere. Go to the on click. Drag it in, video playback, play pause. Okay. So technically we didn't even need to necessarily do that because we can access quite a lot of the functions directly. So if we wanted a separate play button, a separate pause button, a separate stop button, we can do that. Okay. So you can access any of these functions via the on click. A particular note, for instance, is step forwards, okay, which is quite a useful one to step, say, 15-30 seconds forwards into the video. So we now have a basic play pause button. Okay. We have a button that when we click it we can play, okay, and we can pause. What we're going to do is we're going to now enable us to actually be able to look entirely around the video. So look around the scene basically. Okay. We're going to do that using a very simple script. Okay. So we're going to create a new script, okay, called lookx, and we're going to attach it to the camera. Okay. And the astute of you might realise that lookx refers to looking in the x direction, which is basically just looking left and right. Okay. So we'll wait for Visual Studio to open. So we have our script lookx that's going to enable us to look in the x direction, okay, and we're going to set it up to use the mouse, and a little bit later we'll make some changes that let us use virtual buttons. So we're going to add a variable of type float that just sensitivity to make it so that it's more or less sensitive, so that when you move the mouse more or less it's been faster or slower. Okay. And then into update, so every frame which we're going to tell the transform, in this case the camera's position, to rotate 0 around the x-axis, input dot get axis mouse x around the y-axis and 0 around the z-axis. So nice and straightforward. Okay? And then what we're going to do is we're going to times that input by the sensitivity. So press play, and I forgot to add the sensitivity in there. Okay. So you can see I can move around, okay. But I can't yet move up or down. Okay. So let's add a new script to our camera, okay. And we're going to call it coincidentally look Y. Exactly the same setup before, so we're going to add public float sensitivity. Say transform dot rotate. Okay. This time, instead of rotating around the y-axis, okay, we're going to rotate around the z-axis. So input dot get axis, okay, and this time we want mouse Y, 0, 0, okay, and again we'll type that by sensitivity. So again we can look up and down, that's that. And if I go back and remember to add, so not in play mode, we can look and we get some strange results, okay, but we can actually look around quite a bit. Okay. So using the mouse is fine for simple things, but actually for some stuff we probably want instead to be able to use buttons. Okay. So using buttons is a bit more difficult than just adding in a button and adding in on click, because it requires you to actually have the functionality to hold and press the button down. Okay. If I just add that back in, that should delete it. Okay. So we've got a button here that's play. Okay. Now what I'm going to do, and I'll do 2 examples and I'll leave you guys to do the other 2, is I'm going to create 2 buttons, 60-60, and I'm going to cheat, and again you guys can make these much more stylistically pleasing. I'm just going to cheat, and I'm going to have one to kind of rotate upwards and one to rotate, say, to the right. Okay. Instead of just using, so if you've done what I've done, duplicate your proof, but make sure you go to your unclick function. So instead of using this unclick, what instead we're going to do, we're going to use the Unity event triggers. Okay. So unclick uses one particular type of event trigger, and that's what it uses. Okay. What we're going to use, we're going to use the pointer up, okay, pointer down, and pointer exit. Okay. So what we want to do is, when the pointer's down, we want to be able to create or rotate the camera in the specified direction. So we're going to have to create some new scripts that move away from using the mouse, okay, and instead use these particular scripts. Okay. So that's in fact what we're going to do. So what I'm going to do, I'm going to create a new script, and I'm going to call it rotate buttons. And we now have the ability to add in and to be able to set up the code for our buttons. So we need a very similar start to the other examples. Okay, so we're going to set sensitivity to 1. Okay. This time we're also going to have a string that tells us which direction. Okay. So we could create separate functions, separate ways of working for each and every single direction. But actually, we're going to take advantage of parameters, take advantage of being able to set these sorts of things, and instead just use that particular direction variable to set the value. So I've created a new function called rotate, and it takes in string direction. Okay, so now you might have noticed that the 2 names are the same. Okay? So the string direction is a parameter. It basically classes a local variable within just this function. Okay? And direction is a global variable for the whole script. What we could do instead is, okay, so we can say this direction, which will mean the direction belonging to this script is equal to direction, which is the direction we pass it. Okay. I could very easily change parameter name, and that's what I do. I just wanted to kind of show you this just to bring it to your attention. Okay. So all that function is doing is when we click a button, okay, when we kind of press the mouse down over the button, what it does is it then passes to some code, or to this script I should say, the direction we want to move in. Okay? The bit that is kind of controlling the movement is one of the things that we'll do within update, because we want it to happen every frame. Okay? So rather than have it so that when we press the button and it kind of moves incrementally a little bit, okay, we want it to move smoothly. Okay? So what we're going to do is I'm going to show you so we have transform.rotate. Okay, so rotate the camera 0 around the x, minus 0.2, because if we want it to move left, minus is moving to the left manner, and time by sensitivity just as before. And we'll break. I've got my colon there. Okay. Case rate. We're going to do exactly the same, okay, but we're going to move it in 0.2 direction. Okay. Case up. And we're going to go this way. Yep. Okay. And I'm just going to copy this bit for down. I'm going to swap the minus. Okay. And finally, we're going to have our default case. And our default case in this case is just going to be basically anything else. Everything up, we basically want it to stop, want it to not rotate. Okay. So it's left, we'll rotate left, right, rotate right, up, upwards, down, downwards. Okay. So this is passed from this function here. Okay. So then it's time to connect it all up. Okay. So in Unity, wait for the script to compile. Our upward button, okay, here. I'm going to go to, well, I'm going to go to anything at the moment. We're going to go delete these. Okay, so we'll delete that. Look at Y script off, moving off the camera, just so that we can not have to worry about the mouse control overriding. Okay, and then what I'm going to do is, when you press the pointer down, drag the main camera into here, rotate buttons. Okay. Okay. So this is the up button, so we're going to go up, okay. Pointer up, rotate, and we're going to give it blank. And what I'm going to do is, well, just do pointer exit. It's exactly the same, just so that when you move your mouse over it, it stops as well. Okay. So that means I can now magically rotate all the way around. And I could, if I wanted to, I could add a max angle, so maximum, so that I can't go above a certain time. So normally about 30-40 degrees is quite a good area. Okay. But I'm just going to leave it like that. Okay. And you can do exactly the same thing. Okay. Event trigger, add your new event types for right. So pointer down. Okay. Add your event that you want to happen. Right. Make sure they're spelled exactly the same, including capitals, as they are in the script. And then go up, go right. And if you noticed, I didn't add the pointer exit, so there's no pointer exit on here. So that's something we want to consider. if you look at the camera, you'll find that actually one of the things that you may want to consider is the fact that your rotation, when you add the rotations up, they can actually lead to some quite strange rotations. Okay? So it's one of the things that you may want to consider, okay? And we'll look at a way to do that. So at the moment, when we try to move, it has a weird behaviour of moving in the direction we expect, so up and down and left and right. Okay? But actually, when you start to move and you're already facing in a different direction, it kind of had this weird thing of tilting it diagonally. Part of that because of the way that angles behave in a 3D space in Unity. So instead of actually behaving separately, the angles and the rotations that you use are actually multiplied together. Okay? And you can actually get some really weird reactions. Behind the scenes, Unity uses a system called quaternions, which are a relatively complicated way of actually describing your and showing your different angles. Okay. But actually there are some easier ways than having to go through and set your z-axis to 0 and all sorts of bits and pieces, to use the simple transform.rotate and still get the behaviour you expect, which is using something called different world spaces. So our camera, what we expect is that when we rotate it by from the x-axis, okay, it looks up and down. When we rotate it y, it looks left and right. Okay. So what we can do, we can set our rotation to be about different spaces. Okay. What that means is that you rotate about different points. So the two we'll use world space and self space, okay, or local space. Okay. So world space rotates it around a point in the world, and self space or local space rotates it around itself. Okay. And there's a good rule of thumb to follow, which is that for each of your transforms, if you're rotating like this one is about the y-axis, so you're looking left and right, okay, good rule of thumb is to say, okay, the space you're ready to, okay, is world. Okay. So for the first two, if we put space.world, and then the second two where we're rotating about the z-axis, okay, so we're looking up and down, self. Okay. This now means that hopefully when we go to Unity, okay, we get a rotation more akin to what we were expecting. Okay. And we can look around, relatively similar to what we were expecting, hopefully. And as discussed earlier, what you could do is you could quite easily clamp those values. Okay. One of the things I noticed was that I didn't add in to this one the point up event, so when I click it, it just keeps rotating and click on something else. Okay. And you could do all sorts of things to give it a more realistic appeal. Okay. There's also a couple of other bits and pieces you could do. Okay. If we're intending this to be used on an app, we could add in gyro controls or drag it and swipe controls. Okay. We could add in playlists. We could add options to hide the GUI. Okay. All of which are relatively straightforward to do. Okay. Hiding the GUI, it's just a case of having a button that either hides buttons or in some cases panels, or just hiding the canvas. You can have buttons that load preloaded videos, okay? And again, it's just a matter of
feeding that video into the video clip section. Okay. So accompanying this, I'll have some tasks for you to undertake. Okay. So finishing off the video player, adding in things like some extra buttons, adding in some stuff that makes it a bit prettier. Okay. I'll also add in some UI elements to make it look a bit nicer. Okay. I'll add in some challenge tasks, okay. And you can get quite a nice example of a 360 video player running on your computer, and you can build it to your phone. So for instance, with a bit of finagling, this would build quite nicely into an app. You could build it for desktop, okay? Or you could build it for VR, and as I said, I'll cover that in a future video. Hopefully you found this useful, and hopefully you've succeeded. Drop me a message if so. Okay. And hopefully the challenge stuff will really get you to start thinking about how you could extend this into something a little bit different.